Assalamualaikum and hi class, welcome to Strength of Material class. Today we would like to perform Shearing Force Lab, which is B3. As for the objective, at the end of the lab session, students should be able to study the relationship between shear angle and shear force. Second, to determine the modulus of rigidity of a material. For the theory, force will produce the effect of a shear force on the bar if the force is perpendicular and no moment applied at the cross-section. The action of force at the cross-section area will produce shear stress, which is tau equal to Fq over A. Tau is shear stress and A is cross-sectional area. In this experiment, the cross-sectional area is 3,750 mm². Angle of shear, when the force is applied to the A, the part will experience the displacement refers to the B. In this case, assume that distance between part A and part B, which is L original, is fixed. A part of this displacement angle is known as shear angle. In this experiment, L original is 92 mm. Modulus of rigidity, all material will have different level of shear as constant of a material. The constant shear is the modulus of rigidity, G. So G is tau per shear angle. A modulus of rigidity, G, of the material in this experiment is 0.42 Newton mm². So this is the apparatus that been used in this experiment, which is rubber in-shear apparatus. Next is dial gauge. Set the dial gauge into 0. Weight holder. Okay, first measure the bar. So the length of the bar is 75 mm. And measure the weight of the bar, which is 50 mm. And also the L original. So this is your lab sheet. Weight holder, load, this one is 5 Newton and 20 Newton. Place a weight F on the hook starting with 5 Newton and get the dial gauge reading. Add weight to carry forward cycle in increment of 5 Newton until the total weight of 100 Newton and seek to achieve dial gauge readings for each additional weight. Fill in the result into the table 1.1 in your lab sheet. For discussion, plot the shear stress, tau versus shear angle graph and get the slope being the value of G. Comment the relationship between shear stress and shear angle and then compare the value of modulus of rigidity obtained by the actual value of G. And then calculation method. Show the example of calculation that used to get the value